Hey class, it's time for our 1.3 video over scientific notation. Now, when it comes to scientific notation, it can seem really complicated because we're taking really big or small numbers and squeezing them down into what seems like a math equation. And because of that, it can be kind of overwhelming sometimes. But it is an amazing tool to allow us to represent these numbers in a way that makes sense. So, when we talk about scientific notation, like I just said, scientific notation is a way to express large or small numbers that cannot be conveniently or easily written because of their size. So essentially, the numbers are so large that we're writing out like 20 zeros, or we just have a bunch of random digits, and it's honestly not convenient or easy to write out. So instead, what we do is we decide to write them in a condensed fashion. Now, how these work is that the numbers will be written as a number less than 10. So numbers are written less than 10, where we have a blank followed by times 10 to the, and this is a math term, an n, which basically represents like any number. So an n, which indicates the number of spots the decimal moves. Now, that's a lot of words there to start. Don't worry, we're going to get some practice here, some examples. But what we need to know is if n is negative, so if n is negative, it equals a small number. So our decimal will move left. And if n is positive, it equals a larger number. So the decimal moves right. So let's get some practice here going both ways. So in that means, so we're going to have some big numbers, we're going to have some small numbers. So we're going to start by looking at what happens when they're in scientific notation, going out of scientific notation, and then we'll bring them into scientific notation. So, for instance, some examples here. Let's start with 2.4 times 10 to the 4th meters. Now, to be very clear, this right here is just the unit, so that doesn't affect us here yet. But what I do is I can take this number 2.4 and I will drag that decimal out to the right 1, 2, 3, 4 spots, and then fill in with zeros. So it's going to be 2, 4, and then 1, 2, 3 zeros meters. It's going to be 24,000 meters. All right, I'm going to erase that. Let's look at another example here of 3.4 times 10 to the negative 6th kilograms. Now, again, so now we're negative, so our decimal is going to move to the left a certain number of spots, in that case 6. So 1, 2, 3, 4, 5, 6. Plot it there. These spots would then get filled in with zeros, which means I have 0.5 zeros, 1, 2, 3, 4, 5, 3, 4 kilograms. All right, now let's look at 6.26 times 10 to the 8th meters per second. Again, this right here, just a unit, doesn't actually matter to us right now. So that means I'm going to move the decimal to the right 6 spots. So I'm going to have to move it twice to get to the other side of my numbers that are here. And then the rest are just going to be zeros. So that would mean 6 to 6 and then 6 zeros to go on it. So that is 626 million meters per second. Something's moving really fast. All right, lastly, one more example, 8.493 times 10 to the negative second seconds. So then again, I would look, it's easier to go to the left, 2 spots because of that -2, fill in with a 0. So that would be 0.08493 seconds. All right, so that's going in or out, or that's going from out of scientific notation. Now we're going to look at going into scientific notation, so kind of the reverse process here. So I'm going to take a number such as 3,000 meters. Well, I need to get this to the point where it is under under 10. So that would mean I would need to take my decimal, which exists here on the end, and go 1, 2, 3 spots. Well, because it's a large number, I know I'm going to have a positive n value on that times 10. So this is going to be 3 times 10 to the 3rd meters because it's a large number, so I have a positive value there. All right, how about 0.00013 seconds? Well, what does that equal? Well, I have to look at this, and I'm going to drag this 1, 2, 3, 4 spots in to get it to that number that's less than 10, so 1.3. And then I moved it 4 spots, so -4 seconds. Oh, sorry, times 10 to the -4 seconds. So again, small number, so it has a negative value along with it. All right, now we're going to look at another small number, so 0.0024 kilograms. So I'm going to take that decimal, 1, 2, 3. So it's going to be 2.4 times 10 to the -3 kilograms. All right, one more example here. We're going to look at a really, really large number. So 96,200,000. Just a value. It has no unit on it there. So let's take our decimal, which exists at the front, to go 1, 2, 3, 4, 5, 6, 7 over 9.62 times 10 to the 7th is the value I'm looking for there. So you've seen how we can move in and out of these, and now in class we're going to have a bunch of example problems around the room that you're going to work on. So as you get to class, be ready to be able to convert in between units and in between scientific notation. And if you have questions, as always, please come and check in with me.